We will be looking in this video at lessons 4.1 to 4.3, which gives you a good intro into functions. In this first part of it here, our guiding question is, how can we represent the relationship between variables? And we can represent the relationship between variables by using graphs. Graphs help us to see how variables change. We can see how variable quantities change. Your enduring skill in this lesson will be Math Practice Standard number 1, make sense of problems and persevere in solving them. And you'll be doing this by looking at data graphically, using tables, and verbally. You'll decide if the relationship is linear or nonlinear by looking at this data and also by looking at equations. If we look at this first problem, we're going to look at how we analyze the graph. And if we look over here in our think box, it says, how can you analyze the relationship? Read the titles, and the axis titles will tell you what variables are related. The graph itself shows the representation of the relationship as the variables change. So if I look at this problem 1, if I look at the title, I have air in a balloon. That's what the graph is showing me, air in a balloon. And then I look at the axes. I have the volume of air that's in a balloon and the time. So I'm going to look to see how those are related. So if I look at the problem, it says the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Well, the variables would be our volume and our time. Describe how the variables are related at various points on the graph. If we look here, if we follow along my pen here, it says the volume increases as you blow. It stays constant each time you pause to breathe. Blow, breathe, blow, breathe. And then right up here, all of a sudden, it pops and it goes back down to 0. These two got it problems, I want you to try them on your own, and then we will be checking them in class. In problem 2 here, we're looking at matching a table and a graph. It says here, a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown? So if I look at here the difference between 346 and 101, and then the difference between 101 and 3455, and then the difference between 3455 and 10,426, I see that it's not a constant change. The change is not constant. And since it's not constant, it's not a line. So that means I can rule out A and D. And then if I look and see, I start small and get larger, so that rules out C, which leaves me with answer B. I'd like you to try the Got It problem 2 here, also on your own, and we will check these together in class. Now, if we look here, it said in problem 2, the number of downloads, which was on the vertical axis, depends on the day, which is on the horizontal axis. When one quantity depends on another, you show the independent quantity on the horizontal axis, which is our x-axis, and you show the dependent quantity on your y-axis. So if we look at how that looks on a graph, if I have an X and a Y axis, on my X axis I would have my independent, and on my Y axis here I'd have my dependent variable. So your dependent variable is on the vertical axis and your independent is on the horizontal axis. If we look here at problem 3, sketching a graph, it says a model rocket rises quickly and then slows down to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight and label each section? So if you can see here, first we identify the two variables that are being related. In this case, our height and our time. And the height depends on the time, so I put the height on the vertical axis and the time on the horizontal axis. And then I just start. First, the rocket rises quickly. If we follow what it says here, slows to a stop, stops rising. It begins to fall quickly, parachute opens, and then you'll fall slowly to the ground where it stops. In a relationship, the dependent variable changes in response to another variable, which we call the independent. Values of the independent variable are inputs. Again, there are x's, and the dependent variables are outputs, which are our y's. The value of one variable may be uniquely determined by the value of another variable, and we can represent these using tables, words, equations, sets of ordered pairs, and graphs. If we look here at problem 1, we're trying to find the relationship between the number of rectangles and the perimeter of the figure that they form. We're going to represent it using a table, words, an equation, and a graph. So think first which one is dependent and which one is independent. The perimeter depends on the number of rectangles, so perimeter is dependent, which means the number of rectangles would be independent. So I use this to set up my chart. Always put my independent variable first. And then I have my formula. And then I have my ordered pair, which these values in blue will be my dependent variable, or my y. And these are my independent, which are my x's. So if you just go through and read, you can read through it yourself. It goes through making the table, inputting the number of rectangles into the formula, and then getting the y, and then getting the corresponding ordered pairs. So I get 114, 216, 318, and 420. We can then see that we have a certain equation that we use, y equals 2x plus 2. We have the words that we can use to describe it. We have our table. And then next we're going to look at our graph. Now we can see step 3. We use the table to make the graph. So we've used a table, words, an equation, and a graph to all represent the same relationship. We can describe the relationship in problem 1 by saying that the perimeter is a function of the number of rectangles. This definition of a function, very important. It pairs each input value with exactly one output value. X values do not repeat when we have a function. Y values can repeat. X values cannot. Key fact. We've seen one way to represent a function is with a graph. And a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So when we have a function, we put our independent variable, or our x, into the function. We do something with it, and it spits out our y. I would like for you to do this Got It number 2A problem on your own, and we will look at it together in class. Here we have our concept summary of our linear and nonlinear functions. Linear functions form a line that's non-vertical or part of a non-vertical line. So all of these are linear functions. Nonlinear functions form these other types of graphs. Linear functions have an x in the first degree, which means you'll have something like y equals x or y equals 3x. Examples. This type of function has y equals x and you have it squared. This type of function will have y equals x cubed, and this last type of function is an absolute value function, and it will have your x as part of the absolute value. And we'll talk a little bit about this in class. And lastly, a function can be thought of as a rule that you apply to the input in order to get the output. You describe a nonlinear function with words or with an equation, just as we did with linear functions. Sometimes they're a little bit harder to figure out though. So I'd like for you to read through problem 3 here, and then see what you can do about the Got It problem 3. Again, we'll look at this a little bit together in class, but read through problem 3's examples closely. Look at the think box over here. How can you use reasoning to write a rule? Write a rule based on the first 1 or 2 rows of the table, and then see if it works for the rest. So you've got to check it for every pair of numbers. Just kind of follow through the problem, read this problem closely, and we'll talk about it in class.